Okay, so in this video, we're going to start the next section of notes. But before we do that, we're going to answer this do now question based off of the notes that you took last class over valency electrons. And so try to use your notes and try to use your periodic table to answer this do now question. Okay, so the question says, which of the following elements does not have one valency electron? Okay, so try to answer that question on your own. All right, so to answer this question, we need to take a look at the periodic table, which I'm going to pull up my periodic table. And just to remind you, a valence electron is an electron in the outer shell of the atom. Okay, and so in the last video, we talked about how electrons live inside shells, and if you think of them like different layers, right? Let me color this. Um, the inner shell can hold 2 electrons, 1, 2, and then the next layer. Actually, let me do the electrons in black. The next layer can hold 1, 2, 3, 4, 5, 6, 7, 8 electrons. And then the next layer after that can also hold 8 electrons. Okay, the next shell. Okay, so this would be like the third shell right here, and that can also hold 8 electrons. And so when we're talking about, so 1, 2, 3, 4, 5, 6, 7, 8. And so when we talk about valence electrons, we're not talking about how many electrons an atom has, but how many electrons does it have in the outer shell. And so in the last video, we kind of talked about how all of the elements in group number 1 have 1 valence electron, and all of the elements in group number 2 have 2 valence electron, and then 3, 4, 5, 6, 7, and then 8. And so this last column, group 18, all of those atoms have 8 valence electrons, which means that their shells are full of electrons. That's why group 18 is called the noble gases, because all of those gases, because they have 8 valence electrons and their shells are full, they basically don't want to gain or lose electrons, and so they're not likely to react with other stuff, and that's why those are the noble gases. Okay, but based off of this that we talked about last class, you can see that everything in group 1, like lithium, sodium, potassium, rubidium, and cesium, all of those have 1 valence electron, right? And so if we go back to the do now question, we can see the one that does not have a valence electron would be oxygen, because oxygen is over here in group 16, and oxygen actually has 6 valence electrons. Okay, and so the answer to that question should have been D, oxygen. Okay, so moving on, we're starting our next set of notes today. This is ionic and covalent bonding. This is 3.3. And so if you don't already have your notes for 3.3, you should be able to get them from the IPC bin at the front of the classroom. So go ahead and pause it here and do that now. Okay, so we're going to talk about bonding today, and there's 2 main types of bondings. We're going to talk about ionic and covalent. And so when we're talking about a bond, what we're basically talking about is how can different types of atoms come together and form compounds. Okay, so for example, water is an example of a compound because it's H2O. It's made of hydrogen and oxygen. And so those atoms are held together in some way, right? And so the way that atoms can stick together is called bonding. And the 2 main types of bonding are, again, ionic and covalent. And so we're going to start off by talking about ionic bonding and then talk about covalent bonding next. Okay, so before we start talking about bonding, we can talk about why do atoms form bonds? Okay, and so atoms, the reason atoms react with each other the way they do, or the reason they bond together the way they do, is because of those valence electrons, right? So the electron shells hold a specific number of electrons, and we just talked about that, right? Most shells hold 8 valence electrons, although the first one holds 2, right? And so when you have a shell that is full, the atom becomes stable. In other words, if I am an atom, my goal in life is to get my shell filled with electrons. Okay, that would make me really, really happy, and then I would be a happy, complete atom. Okay, and so atoms are the most happy when they have their shell filled with electrons. And again, that's either 2 electrons for the inner shell, but for the outer shells, usually it's 8 electrons. Okay, and so the reason that atoms bond together is because they bond in order to fill their shells, in order to get a complete shell. Okay, they want to be complete. Okay, and then this bullet point right here says that neutral atoms with complete shells are called inert. Which elements are inert? Okay, so I talked about this a few minutes ago, but the atoms that naturally have their shells complete are the ones in group 18, and those are called the noble gases. Okay, and because they're in group 18, those ones automatically have a full shell of electrons, and so they're already happy. This word inert, if you don't know what inert means, that basically means does not react. Okay, and so those noble gases, they don't bond with other atoms, they don't cause chemical reactions, they don't really do anything exciting because their shells are full. They're happy atoms. Okay, but all of the other atoms, for the most part, can bond or with each other, react with each other because they don't have filled shells, right? So it's only the ones in group 18 that have complete shells. So pause there and make sure you add that to your notes. Okay, so on this slide, the notes say an atom will bond with as many atoms as it, oops, an atom will bond with as many atoms as it takes to fill its outer shells because it wants to have its shell full. That would make it a happy atom. Once that shell is full of electrons, the shell is stable and the atom is no longer going to react. Okay, which is just kind of what I talked about before. And atoms can either stick to each other or they can stick to other atoms. Okay, so just to give you an example, when you talk about like water, water is H2O. Okay, so in this case, we have hydrogen sticking with oxygen, right? And so those are two different elements bonded to each other. But there's also a possibility that you have oxygen, you actually have two oxygens bound to each other. Okay, so atoms can either bond to each other, like you see here, or they can bond with other types of atoms. Okay, either way, this is what's called a compound because compounds are formed when two different atoms bond together. And we talked about that like in a previous unit. So like water is an example of a compound because there's two different atoms. Or we also talked about like NaCl, which is table salt. It has Na, which is sodium, and it has Cl, which is chlorine. And when you bond those two together, you get a compound because it's two different atoms. Okay, so let's start off by talking about ionic bonding now. Okay, so there's two main types of chemical bonds, ionic bonds and covalent bonds, and we're going to start talking about ionic bonds. Okay, so make sure you fill in your notes. Okay, so ionic bonds exist between a nonmetal and a metal. Okay, and so you should have already labeled your periodic table with metals and nonmetals, but ionic bonds don't exist between nonmetals and nonmetals, only nonmetals and a metal. In other words, you typically have one thing on the left side of the periodic table, which is a metal, and then one thing on the right side of the periodic table, which is a nonmetal. And the way an ionic bond works is that the atoms actually exchange electrons. Okay, and another word for exchange is swap. They actually swap electrons. Because remember, the goal to be bonded is you want to get your shell filled. Okay, and a full shell normally has 8 electrons. You want 8 electrons in your shell. Okay, in your outer shell. Okay, you want 8 valence electrons. And so usually the way this works is the metal is going to lose electrons, and the nonmetal is going to get those electrons, and the metal, when it loses electrons, is going to end up with a full shell, and the nonmetal, when it gains the electrons, is also going to end up with a full shell. Now, in the last unit, we talked about what happens when an atom gains or loses an electron. It becomes what's called an ion. Okay, so remember, when you have a neutral atom, you have the same number of protons and electrons. When you gain or lose an electron, you have what's called an ion, either a positive ion or a negative ion. Okay, so this is why this is called ionic bonding, because it involves gaining or losing electrons. Okay, so it involves ions. That's why it's ionic bonding. Okay, so going to the next slide. Okay, so let me give you an example of how this might work. Okay, so let's take calcium for example. Calcium is in group 2. Okay, so calcium is right over here in group 2. How many valence electrons does calcium have? Well, we've learned before that group 2 elements in group 2 have 2 valence electrons, right? In other words, they have 2 electrons in their outside shell. Okay, that doesn't mean they have 2 electrons, it just means they have um, 2 electrons in the outermost shell. Now, how many electrons does it need to be stable? Okay, and by stable I mean a filled shell. Well, now there's 2 possibilities. Okay, so calcium has 2 valence electrons. Okay, and a filled shell normally has 8 valence electrons. Okay, so there's basically 2 things that calcium could do. Calcium could either gain 6 electrons to become stable, or it could lose 2 electrons, and then there would be no more valence electrons. Okay, and then what would happen is you would go down to the next shell, and that shell would already be filled. Okay, and so there's 2 ways that calcium could become stable, either by gaining 6 electrons or by losing 2 electrons. Okay, and then the outer shell is just going to go away, and then the next layer is already going to be filled from before. Oops. All right, so either it can gain 8 or sorry, either it can lose 2 or gain 8, which one is easier? The answer is losing 2. Okay, it's not likely to gain 6 electrons just randomly, but losing 2 electrons is a lot easier than gaining 6 electrons. Okay, and so what's going to happen is that under the right conditions, it can lose 2 electrons, and then it is going to become a positive ion, right? Because if it's just like a normal atom, it's going to be neutral, and it's going to have the same number of protons and electrons. But if it loses 2 electrons, remember electrons are negative, then it's going to have a positive charge, and it's going to become an ion. Okay, and actually the same thing would happen to all of the other elements in group number 2. And so if you want to fill in this chart right here, this chart just kind of shows you which elements would naturally become ions. So in group 1, all of those elements in group 1 would tend to lose 1 electron and become a positive 1 ion. All of the elements in group 2 would tend to lose 2 electrons and become a positive 2 ion. Okay, and so on and so forth. So I would label your periodic table so that you can see what's on my screen right now. Now notice that everything in group 18, those are the noble gases, they're not going to lose or gain any electrons because they're already stable. They already have a filled shell. They're happy. They're good. Okay. On the other hand, in group 17, these have 7 valence electrons, right? And so if you have 7 valence electrons and you want to get to 8, then you need to gain 1 electron. But remember, electrons are negatively charged, and so if you gain 1 electron, that's why your charge becomes negative. Okay, so everything in group 17 would tend to would tend to gain 1 electron. Everything in group 16 would tend to gain 2 electrons, and so on. Okay, so make sure you have that down in your notes. Okay, so how do ionic bonds work? Okay, so imagine you have lithium and chlorine mixed together. Okay, lithium and chlorine can actually bond together ionically, meaning that they can form ionic bonds. Okay, so if you were to do the Lewis dot structure for lithium, it would look like this because lithium is an alkali metal in group 1, it only has 1 valence electron. And chlorine is in group 17, and so it has 7 valence electrons. Okay, so what's going to happen is when you mix lithium and chlorine, this electron is going to fall off of the lithium and come over here to the chlorine. And so now the lithium has no valence electrons, so it's happy. The chlorine now has 8 valence electrons, so it has a full shell, so it's happy. And because you're exchanging these electrons, it makes the lithium and chlorine stick together. Okay, and so what you're actually going to end up with is what's called LiCl, which is lithium chloride. Okay, and so that lithium and that chlorine are bonded together now. Okay, because they basically swapped electrons and now they're stuck together. Okay, so that is an example of ionic bonding, right? You have an electron come off of one thing and swap to a different atom, and because of the swapping, they end up sticking together. Okay, so that is a classic ionic bond. Okay, so here you can just see that they both now have complete outer shells. The lithium is going to lose an electron, so it's going to be a +1 charge. The chlorine is going to be a -1 charge because it gained an electron, but now they both have complete outer shells, and so now they're both happy atoms. And because one is positive and one is negative, they are attracted to each other. Okay, and it's kind of hard to see um, that, but there you can see at the bottom it says positive and negative lithium and chlorine ions are attracted to each other because positive and negative attract. Okay, if you've ever heard opposites attract, that's where that comes from. Positives and negatives attract. Okay, so that is an example of ionic bonding. Okay, so here are some properties of ionic compounds. Ionic compounds have a high melting point, they are good conductors of electricity, and they tend to be solid at room temperature. Okay, so think like table salt. Table salt is an ionic compound because it's Na and Cl, and that is an ionic compound. Okay, so that is a solid at room temperature. So we're going to answer some questions in Pear Deck, or either in Pear Deck or Edpuzzle, based off of what you have in your notes so far. Okay, so example 1. Which of the following is not true regarding ionic bonds? Okay, so read the answer choices A, B, C, and D. Which of the following is not true? Okay, so try to answer this question on your own. Okay, so A says ionic bonds form between metals and nonmetals. That is a true statement. Okay, because you have to have something gaining an electron and something losing an electron, so that's why it has to be one metal and one nonmetal. B says ionic bonds involve an exchange of electrons between atoms. That is also true because you have electron swapping. C says the alkali metals in group 1 all tend to give up an electron to gain a charge of plus 1. Okay, that is true. You should have already put that in your notes. All of the elements in group 1 tend to lose an electron. That way they have like a full outer shell. And so that is true. And then D says the noble gases in group 18 tend to gain an electron to gain a charge of -1. That is not a true statement, right? The noble gases already have like a full shell of electrons. Like they're happy, they're good. That's why they don't react with stuff. That's why they are inert. And so D is definitely not true. Those are not going to gain or lose any electrons. Their shells are full of electrons. Okay, so hopefully you got D for your answer choice. All right, next question. One example of an ionic bond is between sodium, Na, and chlorine, Cl, to form table salt. Which of the following correctly describes the charges of these ions? So pause it here and try to answer that on your own. Okay, so the correct answer is A. If you look back in your notes at your periodic table, Na is in group 1, and all of the group 1 elements tend to lose 1 electron and become +1. And Cl is in group 17, and all of them tend to gain 1 electron and become -1. Okay, so that's just straight from your notes. As long as you know where Na and Cl are, you can figure that out. Okay, but you have to look at your periodic table to answer that question. All right. And then I think we have one more question and then a quick video. A scientist investigates whether or not an unknown compound is ionic or covalent. Which of the following observations would make the scientist believe that the compound is ionic? So try to answer that question on your own. Okay, so ionic compounds tend to be solids at room temperature, so B is out. They tend to have a high melting point, so C is out. And they tend to be good conductors of electricity, and so D is correct and A is out. Ionic compounds tend to be a good conductor of electricity. And actually, that brings us up to the last thing I want to talk about in this video. Good conductors of electricity. Ionic compounds, when you dissolve them in water, you get what's called electrolytes. And you might have heard of electrolytes before if you've ever drank like Powerade or Gatorade or whatever, like after working out. Okay, electrolytes are basically what you get when you dissolve like ionic compounds in water because they are good conductors of electricity. Okay, and so after you work out or after you sweat a lot, you lose those ions from your body. And so you want to drink like Gatorade or you want to drink Powerade to replenish those electrolytes. Okay, because Gatorade and Powerade have what's called salts. And salts are basically compounds with ionic bonds. And so what happens when you, like I said, when you mix the salts with water, they just become ions. They become electrolytes, right? And so the when you drink Gatorade, that actually has like dissolved like sodium and chlorine in it. It has some potassium in it. It has different types of ions because your body actually uses those ions to regulate how your body functions. And when you sweat or when you work out, you actually lose those ions like through your skin through that sweat, and then you can like end up cramping or other stuff can happen without those ions. And so that's why after you work out, you drink fluids with electrolytes, with those ionic compounds dissolved in water, and then it helps your body kind of fix itself. Okay, so the last thing I'm going to show you is just like a quick video about electrolytes, and then we will be done with this part of the unit. Okay, so hopefully you got the first part of your notes filled in with ionic bonds. Please let me know if you have any questions, and I will see you guys in the next video.